Morning, YouTubers. Imagine that, another stick welding video. This time though, it's going to be a little bit different. We're going to be jumping into 60-10, 60-11 rods, which I know a lot of you guys out there are afraid of these, or you don't like them because you can't run them that well. And trust me, once you get practicing with it and watch this whole video and do what I say, you're actually going to like these rods. They're very, very useful. And they're actually not that hard to run. It's just that if you try and run these like a 70-18 or 60-13, you're going to have all sorts of problems. So I'm going to teach you how to properly run these, the difference between the 60-10, 60-11s, and a whole bunch of other stuff. So let's get into it. So if you watch my other video on 70-18, you're probably going to have an idea that 60-11, 60-10 is probably similar in the fact that even though these are all called 60-10s on this side, this is all 60-11s, that there's actually differences between the rods. So the American Welding Society will dictate certain specifications that say a 60-10 has to meet. So like everything on this side, they're all 60-10s, but they actually run a lot different than one another. And that's what I'm going to get into first here, is explaining that. So a very common rod you're going to find is what's known as the 60-10 5P. And if you look here, this should, well, this one does not say it. It just says American Welding Society A 5.1 E6010. Does not say it. However, this Lincoln, when we look at it, Fleet Weld 5P. Now open this up. See how the rods are red? Most commonly, 5P rods are going to have a red flux, just like this. These ESOBs, despite, move that out of the way, not saying 5P, red rods, pretty much a good indication. Now, 5P rods are going to be a little bit harsher running. They'll chew through a little bit more paint and mill scale and all sorts of stuff. The puddle's going to be very fast freezing, very crispy. Overall, a good rod for, like, I guess, farm use and welding on real scabby material. This rod in particular, the 5P, is not commonly, to my understanding, used in pipe welding. A rod called a 5P plus is. Now this Lincoln over here, now these are both Lincoln rods, but this is a different specification. This is what's called a 5P plus. If you look here, see all them plus signs there? And, oh, upside down. Plus, plus, plus. 5P plus is a rod that runs a little bit more liquidy. It's a little bit less tolerant of welding over mill scale and paint. I mean, very little, but it's slightly less capable. This is the rod that my understanding is most commonly used on root pass for pipe, not the red rods. And the reason is, like I said, it's a more fluid puddle. It doesn't freeze as fast. It's not as crispy. And with the proper settings, you probably have more control over this because the arc's simply not as harsh. There's, again, a third type of 60-10, and that's what I would call this. Now, if we look here, this is just labeled as 60-10. It does not have a red coating. It's not a 5P specification. It's not 5P plus. This is just what I call basic 60-10. Now, this, in this case, is Hobart. I find that this particular rod does not run like the 5P or the 5P plus in most cases. It's similar, but it's kind of its own entity. And what I find very interesting is when you compare the 60-10 rods to this, they are literally, and both of these are Hobart. I mean, look at that. You might not be able to tell, but they're almost identical, which kind of almost leads me to believe that there isn't that much difference between this generic, you know, just 60-10 and the 60-11. I mean, the flux might be a little bit different, but I'm telling you, it almost looks like they just stamped a different part number on it. I'll know when you actually run these, because 6010 smells more like burning paper than 6011. But I would hope that these are different, but again, very similar in overall look, and honestly, they run very similar. Now, the last rods we'll be running are 6011, which this is a 6011 here. 6011 and 6010 run very similar. Now, it's very common to see 6010 used on job sites, and that's because work will often specify that. Very rarely is 6011 specified. 6011 is a great rod for you guys with Lincoln Tombstones and Miller Thunderbolts and all you home welders that have, you know, older welders, or even a lot of newer inverter welders will run 6011 and they will not run 6010, and it has to do with the 6010 requiring more arc voltage to keep the arc lit. So it's very common, if you ever buy 6010 for your welder and you're welding and everything looks fine and the arc just keeps cutting out, that's because you don't have enough closed circuit voltage to keep the rod running. And in a previous video I actually showed that, but in that case switching to 6011 will give you similar performance, but it should stay lit. And that's just because there's a slight difference in the flux with the 6011, and it helps stabilize and keep the arc lit, and it does that through lowering the voltage requirement to run it. But yeah, other than that, these rods, if you remember from previous videos, let's break it down. 60, the 60 stands for 60,000 PSI of tensile strength. The 1 is referring to the position this can be run. So this is an all position rod. And then the last one, the 4th position, is referring to the flux coating. The difference between these two rods is primarily the flux coating. So I will put up a little image right now that explains the differences in flux composition. When we look here, we can see that 6010 is high cellulose sodium, which typically only runs DC positive, although I have heard of it being run DC negative on pipe. And 6011 is high cellulose potassium, which will run on pretty much any polarity. Now, both of them still use cellulose as a primary ingredient in a flux. It's just the secondary ingredients are different. Let's take a look too at the spec sheet for this particular 6010 through Lincoln. So this sheet gives what the requirements are as far as alloys in the test, and it also gives performance to a certain extent, like the Sharpie V-notch and elongation. And then if you look, this particular rod does specify DC negative. So the previous sheet that showed DC positive only, this shows that it can be run DC negative, which is coincides with what I've heard about welding on pipe. A couple other things I'm going to mention while we're at it here. 6010 is commonly run, at least on piping, pipelining, on the vertical down position. Unlike 7018, which is not specified for that use, you can run 6010 vertical down. Now on open root pipe welding, or even multipass, not a huge issue. If you're trying to weld some structural steel vertical down, probably not the best idea. The penetration becomes more limited running it vertical down. Just something to think of. Another thing worth mentioning is if your welder has what's known as dig or arc force control, these rods you want to run in a higher dig setting generally. And the reason for that is these rods are meant to penetrate very deep and have a very aggressive arc. And that aggressive arc comes from the atmosphere that the rod creates as a flux burns off and melts off, and it creates basically 100% CO2 and creates a very aggressive arc. So that's why you primarily want to use these. On old scabby rusty steel to get a good first pass of a multi-pass weld, great rod, or just as a single pass where you have poor fit up, the weld puddle freezes fast, which really helps you weld big gaps and stuff because you can manipulate the rod to stack metal, and then you kind of pull out of the molten pool, let it cool fast, and then go back into it, and you can end up filling up huge gaps pretty easily with 6010, 6011, which is one of the reasons it's so useful. Beyond that, like I said, arc force wise, my welder, I'm going to be running the 1/8 inch rods at about 90 amps and arc force around 65 to 70%, so pretty high. That's the way I like to run it. So let's actually do some welding and do some learning. So this is an 1/8 inch rod, 90 amps, 65% dig setting or arc force. So you can see there's quite a bit of small hot spatter coming off of it, and it definitely sounds like an aggressive arc. So one of the first things you're going to notice here, a little hot. This is a very rough appearing weld, at least on face value. And unlike most other rods like 6013 and 7018, you'll never get slag peel off of this. If anyone claims they got slag peel off of a 6010 or 6011, they're lying. Don't believe them. Even if your welding instructor says that, he's lying. So you can peel off some of it if you let it cool just by brushing it, but you can see there's still a lot on there. I'm going to use a normal brush. That will get a lot of it. Still not the cleanest. My recommendation, if you can, is to use a wire wheel on a grinder. So that's kind of what I'm going to do. So let's take a look now. Much cleaner. There's still some slag in the toes, but not bad. Now, it gives a pretty rough bead appearance. I mean, it kind of looks cool. It's like a rough stack of dimes and all. But this was the red 5P. Very harsh arc. You could probably hear that when I was welding it with it. Very fast freezing weld pool. As soon as you move forward, it freezes. And that's why you can get this ripple stack of dimes look, is simply because the weld pool solidifies so fast that any manipulation you're making with that rod, any inconsistency, will be left behind. With 7018, 7024, that weld pool is so liquid that if you're oscillating like this, the weld pool, by time it solidifies, is still going to be fairly smooth. You won't get ripples like this because it just stays liquid too long. But this rod, you can stack metal like that, which is very useful for poor fit-ups, wide gaps, because you can stack it on top of the freezing or the solidifying metal. That's looking pretty good. What I'm going to do now is I'm going to run the 5P Plus rod, same amperage, 1/8 inch rod as well, and I'm going to run that real close to this, and then we're going to take a look at that one as well. You may notice that this arc sounds a little less harsh. The spatter looks to be about the same, but it's a little bit quieter, a little bit softer. And in the future arc footage in this video, you're going to see that there's a puddle difference as well. I don't know if you noticed too that the travel speed is actually very slow. Like, it's taken me a long time to make it to the other end of the plate, especially compared to like a 7018. The reason the arc cut out is my foot was on the cord and I couldn't move it anymore. Whoops. So I had to cut out, move my foot, and then restart. Again, you're not going to get slag peel with any of these rods. You can clean off a lot of it with a simple chisel and a brush, but My opinion is you're better off with the wire wheel on a grinder. Now, if you look there, you see it has ripples. You can see my little bit of a rough restart. But the ripples are overall more, I guess, smoother, like they're less defined. Same amperage, but you compare 5P plus versus 5P. A little bit more liquidy of a weld pool, a little bit slower of a freezing rod. Tends to wet out and makes better overall looking welds, I find. I mean, 60-10 5P red rods are real rough running bastards, but not too bad. And again, this rod, the reason so many people have a hard time, and I can't count how many times people tell me, oh, I hate 60-10 or 60-11, and they struggle to make this consistent with bead. I mean, is this an ugly weld? I would say not really, but if you don't know what you're doing, it can really make quick work of something and just make you know, terrible looking welds. And the thing I find is anyone who can't run a consistent 70-18 where it's equal in width and height and straight and all of that, when you go to 60-10, any failure in technique you have with any other rod is just simply magnified by like 10 with this rod. So if you can't perfect any of the other rods, it's just, this is gonna make you look like a terrible welder. But like I said, it comes down to having a slower forward speed, because this does not deposit much metal. You have to let it fill. You cannot travel as fast as with 60-13, 70-18, all of those. And keeping that consistent arc gap, a slight forward, backward, or, you know, kind of stitch motion, long arc, and then dig it, that sort of stuff will all help you get beads that look, you know, pretty consistent like these are. So let me go cool this plate and let's do some more. So in this arc footage, we're looking at the Hobart gray rod. I want you to pay attention when I move forward, how fast that round circle of a weld pool follows me, and how the area right behind that circle of molten metal, that eye, instantly goes from red to black. That's how fast the molten metal's turning solid, and that's why this is known as a fast freeze rod. It's also why your welds, if you don't have good consistency, will look terrible, simply because any inconsistency in your travel speed is captured by the weld. Now this rod, which was the unclassified, neither 5P nor was it the 5P plus, I would say is closer to 5P maybe. It actually kind of ran more like a 60-11, to be honest with you. Let me move this. You can see again, it's more wetted out, flatter, kind of closer to this. It's kind of like almost in between the two. The welds are more distinguishable than this, but not quite as this. Interesting. Now, running that, the pool seemed to be more liquidy than this guy right here. So, pretty interesting. What I'm going to do now is I'm just going to shoot arc footage of a bunch more of the 5P, the red rods. I'm going to do 2 passes, and then I'm going to do 2 passes with the 5P plus, and we'll compare those two. So both of these rods are going to be 5P red rods. Pay close attention to how much that puddle follows the rod. Like, it does not want to extend out any further than the distance that it is, which is a good indication that that molten puddle is solidifying very fast. Again, this is red 5P rod. So this is the gray 5P plus rod. Pay attention to how that molten puddle kind of lags behind the rod. As I move the rod, the puddle almost stays at the same point and then it catches up. So the puddle's more fluid, it doesn't freeze quite as fast. Again, this is gray rod 5P plus. So let's do a recap on what we got thus far. These are the first 3 welds I ran. So red rod 5P, 5P plus, unclassified 6010, all slightly different from one another. Then I ran 2 5P red rods, and then I ran 2 5P plus gray rods. Now you can tell how distinguishable this weld is, and this is a little bit less, but I did not cool a plate between these 2 welds. I did after this one. So heat input will change. The higher your amperage or the hotter the plate is will change the distinct ripple pattern because it affects how fast the weld solidifies. Now, switching to 5P plus on a cool plate, it more or less looks even smoother than 5P on a hot plate. And then I cooled it off after this passing and ran this, and you can see being close to the edge, heat input was very high, and look how smooth that weld is overall. And that's because that puddle stayed liquid for far longer. As I moved and stitched forward a little bit, that weld pool was staying liquid far behind the rod, and I'm sure if you paid attention in the video you would have saw that. And I'll even put a comparison up right now so you can see what I'm talking about. 5P red rod is on the left and 5P plus is on the right. You can see how much more liquidy that puddle is on the right with the 5P plus versus the left. The puddle pretty much stays right on that red rod. As you saw in that comparison, there are subtle differences between the puddle with these, especially, as the plate gets hotter, you run more amperage. This is about what you want to look for all of these when you're running 6010. Doesn't really matter what the rod is, just you now know what to look for depending on what rod you're running. So I think we got this covered so far. I'm going to flip the plate over and then we're going to do some 6011. I'll do probably 2 passes just so you guys get a feel for what you should be looking for, and then we'll go and wrap this video up. Now 6011 needs a little bit more amperage I find than 6010, and here I am running a bit too cold. I had it set at the same 90 amps, but it's really humping up on the plate, and you can see how it's kind of almost depositing like a bead of caulk more than it is wetting out, but we'll run it anyways. This pass with a hotter plate wets out way better. And I had a little bit longer of an arc gap, but you can see totally different story here. So a couple things to note before I go clean this off and cool it. If you look at the first bead, and again, this has flux on it, I didn't clean it. It's far more humped up than the second bead, which laid flatter. And the reason is that I find 6011 needs slightly more amperage than 6010 to lay flat. Or if the plate's heated, it tends to lay flat, because I use new rods for both of these. The other thing that's interesting is the slag is no doubt different. Now, you're not going to get slag peel with it, but it's almost more like a coating rather than just like bits of particulate all over. So a little bit different of a slag coating on this stuff. So let me clean it up and then I'll come back and we'll look at it. So I got this cleaned off and cooled down. It has a distinguished ripples more like a 5P 6010, but the puddle seems to be more fluid, almost like a 5P plus. To me, I would say it's a lot easier to run. It's just, I don't know, it's less harsh than a normal 6010. The results will look very similar. I also found, like you see, this got a little hole there. Now, I had the same thing happen on this side right here because I just snapped out of it too fast without depositing any metal, and the arc basically just chewed away at that. So you always want to be careful at the end of these welds and make sure you kind of bring it back a little bit to fill that in. But yeah, most inverter welders will run with 6010. I don't really use a whole lot of 6010. I prefer 6011, excuse me. Most inverters will use 6011. I prefer 6010 though, to be honest with you. Even though 6010 is harder to get, like if you go in your local Fleet Farm or Menards or Home Depot, very rarely do they ever have 6010, but they do have 6011. So there you go. You know what I'm going to do? I'm going to cut this plate in half and etch it, and we're going to look at the penetration to get an idea of what these rods actually do. And then we're going to go to, I guess, the conclusion of the video. We have interesting results here. The 5P, the 5P Plus, and the Hobart, all very similar. Now in this shot, the 5P Plus has more penetration, but in another shot, it has the same or less in the red. It's just dependent on where you cut the plate at. Now the 6011, that's a different story. You can see the first pass was cold, humped up, no penetration. And in the second pass on a hotter plate, significantly more penetration overall, but nowhere near what the 6010 is. Now there's a couple reasons for that. One, I find that 6011 needs more amperage than 6010. So I was running it a little bit on the cold side. And two, the rod doesn't penetrate, generally speaking, as much as 6010 does. Now here we have a shootout between red and 5P Plus. And as you can see, that one red weld has deeper penetration than the others. It's all dependent on where you cut the plate. But overall, the penetration's looking real good. Pretty wide weld, and not only that, it definitely did penetrate. And keep in mind, I wasn't aiming for huge penetration with these. I should have been running way more amperage and then set my dig a little bit higher, and I probably could have got better than halfway through the plate. Now I threw this in as kind of a eye-opener. The above is 7018 1/8" rod run at a different assortment of amperage, and then the bottom is the 5P run at 90 amps. And you can see the penetration profile is vastly different. What I find is 7018 tends to make wider welds, but the penetration's only in the center of the weld until you get really high in amperage, versus 6010 tends to have a real round profile where it chews in even at the edges. And it's just something to think of. When they call 6010 a deeper penetrating rod, it's not just deeper in depth generally, but it's actually the overall weld sinks in, chews in better. All right, what did we learn today? Well, learned that 6011 and 6010 are quite a bit different as far as penetration, and if you don't have your amperage set right, you get none of it, so that's not good. But yeah, we covered all the bases of the intro to 6010, and you can see there's slight differences among the rods. For your average newbie beginner to 6010, I would recommend finding the 5P Plus rods. You're going to find that your welds are gonna come out a little bit better with that. It has a little bit more leeway in how fast that puddle freezes. So if you shake a little bit or you just aren't quite consistent, it will help you make a better looking weld by a little bit. I mean, we're talking very small amounts, but it could help you. If you're experienced and you have a very consistent hand, the red rod to 5P, you know, you're not going to have any issue with that. And if you're welding on scabby material, honestly, I think both the 5P and 5P Plus will do just fine. I mean, in theory, the 5P will do a better job than red rod. That's what I've heard. Maybe I'll have to pick up some real rusty steel from outside of my place or something, come up with something and just put it to the test. But I have a feeling I could run that kind of test 100 times and, you know, the differences will be subtle to say the least. Now, with 6011, like you saw, if you don't run it at a high enough amperage, which I find it's a little bit over 6010, you will have severe penetration issues. And when I was welding that where it was beaten up like caulk, what I should have done is stop the arc, broke the arc, turned the machine up 10, restarted, and that would have solved that. But for that sake, you know, hey, it was pretty cold, and the cut and etch is probably was eye-opening for me, probably for you too. But yeah, beyond that, if you guys have any comments, questions, concerns, feel free to leave them down in the comment box. Otherwise, I will be doing a bunch more videos, so if you want to see anything in particular covered, just leave a comment on this video and I'll make sure I cover it. But I'm going to show you real good ways to do fill in like poor fit ups where you have big wide gaps. 6010 is your go-to rod for that, you know. But yeah, don't be afraid of this rod. Understand that, yeah, your welds are going to suck and they're going to look terrible at first and you're going to get frustrated. But with a little bit of practice and, I don't know, 20 pounds of rods, you'll be doing just fine. So stick with it. Trust me, this is a very good rod to have in your toolbox if you can run it. All right. Till next time, guys. Take care.